Good morning, students. So since there's a little network issue today, so I'll be sending the recording of this class. I think we were doing this problem in the previous class. A boat take 5 hours to go 300 kilometers downstream. It takes the same time to go 150 kilometers upstream. So we are supposed to calculate the speed of the boat in still waters and the speed of the stream. Okay, I believe we understood the problem in the previous class of how the problem is supposed to be solved and what are the variables that we are supposed to derive. Okay, let's just go through it once again. Now here if you see, it says the boat take 5 hours to go downstream. Okay, so I explained it if this is the stream or any water body. Okay, and the boat is here. Okay, to the corner, I'm just drawing it to the corner. Okay, the boat is here, and if the water is flowing this side, okay, if the water is flowing this side and the boat is also coming from this position, this side, the boat is also coming along with the water, then it is known as downstream. Okay, in downstream it is much easier to row the boat and it will be easy to cover up the distance. So that is why in downstream they are able to cover 300 kilometers in 5 hours. Okay, 300 kilometers in 5 hours. But on the contrary, okay, opposite, if for the same water, okay, for the same water body, if the boat is going, let's say the water is flowing this side, but the boat is trying to go on the opposite side against the water. If the boat, they are trying to row the boat against the water, then this is called as upstream. Okay, anything against will take lot of effort and time. So that is why they are able to row the boat only for, or they are able to cover the distance only 150 kilometers, that is half of the downstream distance. It is not complete 300 kilometers, but it's only 150 kilometers, but the time taken is same 5 hours. Okay, the time taken is same 5 hours. So upstream is against the water and downstream is along with the water. So this is what is the major thing that you are supposed to understand in this problem. Now after this, let us derive the variables required for this problem and we will be able to come to an equation and then solve the problem directly. Okay, so let us define the variables. Now the variables starting with, let the speed of the boat in still waters be x kilometer per hour. Okay, always speed is taken in kilometer per hour. Okay, and then and the speed of the stream is y kilometer per hour. Okay, we are supposed to calculate the speed of the boat as well as the speed of the stream. So that is why we take one as x kilometer per hour and the other one as y kilometer per hour. Okay, now this is the basic definition of variables. Now let us read the question once again. The boat takes, okay, sorry, just wait a second. Okay, read the question once again. The boat takes 5 hours to go 300 kilometers downstream and it takes the same time to go 150 kilometers upstream. Okay, so let me redefine this. Let the speed of the boat in still waters be x kilometer per hour and the speed of the stream be y kilometer per hour. Okay, so this is what we have got. Now after reading the question, let us define the next variable, that is in downstream, the speed of the boat will be x plus y kilometer per hour. Now how this is possible? Now if you see in downstream, as I already mentioned, water speed and the boat speed. Now if the water is flowing this way, water is also flowing, along with water boat is also coming, right? So there is also a speed which is there for the boat. So if the speed of the water is x, if the speed of the boat is x and the speed of the water is y, so in downstream, okay, in downstream the speed will get added up. So that is why it is x plus y kilometer per hour. So that will be the next variable. Now apart from this, we have one more variable to define, that is in upstream, that is against the water, the speed of the boat will be, now in the downstream the speed of the boat and the water was added because the water and the boat was coming together. Okay, there was the water speed and the boat speed was supposed to be added, but here it is going against. When it is going against the water, okay, when water is flowing this way, okay, water is flowing this way, but boat is going the other way. So in this case, if the boat is going up and water keeps flowing this side, it keeps pulling the boat back. So we will minus the speed of the stream. We are not going to take the complete speed of the boat as well as stream. So what we'll do, we'll take only the speed of the boat, that is x kilometer per hour, and we'll subtract the speed of the stream. Okay, so these are the important speed and the variables that we are supposed to derive. Okay, let's just go through all of this once again. Let the speed of the boat in still waters be x kilometer. So the speed of the boat is x kilometer and the speed of the stream, that is water, be y kilometer per hour. Now in the downstream, that is, imagine it's like a waterfall. So speed of the water as well as the boat, both will be considered. So that is why x plus y both is considered here. And in upstream, that is, if it is against the water, if it is going opposite to the water, then in that case we will only consider the speed of the boat, but we will not consider the speed of the water, because water will keep pulling the boat back, or let's say it keeps pushing you back towards wherever it wants to go. So that is why we only consider the speed of the boat here in upstream and not the water. So these are the variables defined. Now let us go on and compare all this and solve the problem by defining the equation. Now the major thing what we are supposed to understand is the formula of distance covered. Okay, now here they have given in 5 hours they will be able to cover the distance of 300 kilometers in downstream, and for the same 5 hours they will be able to cover the distance of 150 kilometers in the upstream. Correct? So what we will do, distance covered, the formula for the distance is nothing but speed into time. Now we know what is the speed. Okay, that is what we have defined here. Okay, x, y, all that what we have defined, and we know what is the time. We know what is the distance covered, 300 kilometers, 150 kilometers. So let us apply all that and derive the equation. But here you will get two equations. Why two equations? One equation for downstream, the other equation for upstream. Okay, so let us define the equation. Firstly for downstream. Now for downstream, how will it be? How much have we considered, or how much distance have we covered? 5 hours to go 300 kilometers downstream. Okay, 5 hours to go 300 kilometers downstream. So we will consider that. So what is the distance covered? 300 kilometers is equal to speed. What will be the speed? Downstream, the speed of the boat is x plus y kilometer per hour. So it is going to be x plus y, that will be the speed, and multiplied with time. What is the time? 5 hours. Okay, so this is the first equation that we will get for the downstream. Okay, later we will get into the proper format. Now that is what we have to do using the formula. Okay, now let us go and derive the formula for upstream. Now for upstream, what is the distance covered? 150 kilometers, half of the distance, right? And what is the speed of the boat? The speed of the boat is x minus y kilometers. So we are going to have x minus y kilometers into the time taken is same 5 hours. Okay, so this is what we will be able to define throughout the problem. If we know so much in the problem, now after this we can only derive the two equations and go on and solve the equations. Okay, now let us simplify these two equations. Okay, so 300 kilometers is equal to x plus y into 5. 150 kilometers is equal to x minus 5 or x minus y into 5. Now here what we can do is, can we write this as 300 is equal to x plus y into 5, which is nothing but 300 is equal to 5 into x is 5x and 5 into y is 5y. Correct? I can write it like this. So I am just multiplying 5 into x and into y. Next, 150 kilometers is equal to same thing, multiplication. So what I am going to do, I will get 5x, but not it's not plus, it is minus 5y. Okay, so I got two equations here. One will be equation number 1 is going to be 300 is equal to 5x plus 5y, and equation 2 is going to be 150 is equal to 5x minus 5y. Now I have 5x plus 5y, 5x minus 5y. Now since I have two equations, I can solve these two equations simultaneously to find the value of x as well as y. Okay, so let us do that, finding the value of x as well as y. Okay, so let us write the equations. So the equations are going to be, thus we have two equations, that is 300 is equal to 5x minus 5y. This is going to be equation number 1, and we have one more equation, that is 150 is equal to, oh sorry, this is 5x plus 5y. 150 is equal to 5x minus 5y. Okay, so these are the two equations. Now let us solve these equations simultaneously. Solving equations simultaneously. Okay, I am going to rewrite the same equation. Here you need not multiply the equations with any number, because both x and y coefficients are same for both the equations. Okay, so we'll just rewrite the equation again. So 300 is equal to 5x plus 5y, and then 150 is equal to 5x minus 5y, and you need not change the sign also. Why you need not change sign? Because there is already minus, plus and minus which is available. So what we are going to do? We are just going to add both the equations here. Okay, we are just going to add. Now when we add both the equations, what are you going to get? You will be getting 450 here. Okay, because 300 plus 150 is 450, and then for x you are going to get 10x. Correct? You are going to get 10x. But 5y plus 5y and minus 5y is going to get cancelled. Fine, plus 5y and minus 5y is going to get cancelled. So we are left out with only 450 is equal to 10x. Now further let us simplify. 450 divided by 10 is equal to x. So what will happen here? We will be having 45 is equal to x. So therefore the speed of the boat in still waters are going to be 45 kilometers per hour. Fine. So this is the first part of the simultaneous equation. Now let us solve the second part of the simultaneous equation, that is by substituting the x value in equation 1. Okay. So substituting x is equal to 45 in equation 1. Okay. So what is equation 1? 300 is equal to 5x plus 5y. Okay, so this is our first equation. Now let us substitute the value. So 300 is equal to 5 into 45, 5 into 45 plus 5y. Okay, so 300 is equal to 5 into 45 is going to become 225 plus 5y. Next, 300 minus 225, sorry, wait a second. 300 minus 225 is equal to 5y. Okay, 300 minus 225 will give me 75 is equal to 5y. 75 by 5 is equal to y. Therefore, y is equal to 15. So the speed of the water is 15 kilometers and the speed of the boat that we found is 45 kilometers. Okay, so that is what we that's what we got. Now let us write the conclusion. Now we got the speed of the boat as well as speed of the water both. Now therefore speed of the boat in still waters is 45 kilometer per hour, that is nothing but x. Okay, so that this is nothing but x that we found out, and the speed of the stream, the water body, okay, the speed of the stream is 15 kilometers per hour. So this is what they had asked us in the question and this is what we found out. Let's just go through the complete answer once again, okay, so that you will be able to understand it better. Okay, so concentrate. A boat takes 5 hours to go 300 kilometers downstream. It takes same time to go 150 kilometers upstream. So we are supposed to find two things: the speed of the boat in still water and the speed of the stream. Okay, so let the speed of the boat in still water be x kilometer per hour and the speed of the stream be y kilometer per hour. In downstream, that is along with the water, if the boat is going, it is going to be x plus y kilometer per hour, and in upstream the boat is going to be x minus y kilometer per hour. Okay, then distance covered is equal to speed into time. This is the formula which you have to remember. Now in downstream, by using the formula, the distance covered is 300 kilometers, the speed is x plus y and the time is 5 hours. In the upstream, the same distance covered is going to reduce to half, that is 150 kilometers, and the speed is x minus y kilometers per hour and the time taken is same 5 hours. Okay, and this, both the formula that we have derived here can be simplified further just by multiplying this 5 to x and y. So I'll get equation number 1, that is 300 is equal to 5x plus 5y and 150 is equal to 5x minus 5y. So this is the major equation that I will get. Now let us take this equation. We have two equations, that is 300 is equal to 5x plus 5y, 150 is equal to 5x minus 5y, and solve this simultaneously. Here you need not multiply any number to the equation since the coefficients are same, and you need not change the signs also because there is already a plus and a minus for y. So just add the equations. So when you add the equations, you end up finding the value of x, that is 45 kilometers. Okay, and then we are going to substitute the value of x in equation 1. The equation 1 is 300 is equal to 5x plus 5y. And once you solve this, you get the value of y, that is the speed of the water. Y is equal to 15. Fine. So here what is going to happen? Y is equal to 15. We get the conclusion at the end, that is the speed of the boat in still water is 45 kilometer per hour and the speed of the stream is 15 kilometer per hour. Okay, so that is your first question. Fine. Now here we come to end of few of the statement problems. I will be sharing few of the other statement problems for you to practice it. Please do practice those problems. Now let us go to the next concept. Okay, that is quadratic equations. Now we have learnt the equations of degree 1, that is linear equations, and we also have solved the problems under 1, that is linear equations problems. Now until here we had linear equation problems of one variable, that is only x, and two variables, that is x as well as y. Fine. So that is what we are going to learn today. This is the next part, or this is the next degree of the equations, that is quadratic equations. Now in quadratic equations, firstly the equation is gonna be in the form of ax square. Now if you see, the highest degree of the equation is square here. So ax square plus bx plus c is equal to 0. Now before you only had ax plus b, right? In linear equations, the equation was ax plus b. So here the highest degree was only 1. But in quadratic equation, the highest degree is 2, and that is why it is ax square plus bx plus c. Okay. Now again you have the condition here, that is nothing but a is not equal to 0. This first coefficient of x square, okay, the coefficient of x square is a, and this should not be equal to 0. Only then it is called as quadratic equation. And this quadratic equation, if you observe, this has only x in its equation form. So this is a quadratic equation of one variable. Okay, what is the variable? The x what you see here is the variable, and it's only one variable because we are using only x. Fine. Next, since a quadratic equation is a second degree equation, it has two roots. Why two roots? Because it is a second degree equation. The highest power is 2, so that is why it will have two roots. Now we will understand how that two roots are derived. The two roots of quadratic equation is called solution of a quadratic equation. This we already know. So once you find the value of x here, the x square here, you will get two values for x. Okay, and how are we going to consider the two values will also be given. Okay, so this is the first introduction of quadratic equation, that is ax square plus bx plus c is the form of the equation where a is not equal to 0. Next, let us learn the types of quadratic equation. Now in the types of quadratic equation, firstly, if the quadratic equation of the form ax square plus bx plus c is equal to 0, where if I say a is not equal to 0. Okay, it's a quadratic equation if a is not equal to 0. Suppose if b is equal to 0, what do we do? B is the coefficient of x here. Okay, suppose if b is equal to 0, then the equation will change. Okay, it will become a little different, wherein this anything into 0 is 0, correct? So if b is 0, 0 into x is, x will become 0. 0 into x will become 0. So this bx completely will get vanished from the equation, and what is left out in the equation is only ax square, okay, is only ax square plus c. This is what is left in the equation. So that will be considered here, ax square plus c is equal to 0. And this form of ax square plus b is equal to 0 is called as pure quadratic equation. Okay, pure quadratic equation is nothing but ax square plus c is equal to 0. If it is in this format, it is pure quadratic equation. But if it is in this format, the normal format, it is called as adfected. Okay, sorry, it's not affected, it is adfected, ADFECTED, adfected quadratic equation. Okay, so these are the major two forms of equation, that is pure quadratic equation and adfected quadratic equation. So this is the first part. Now let us see how the two roots of the equation can be derived in a quadratic equation. So solution of a pure quadratic equation. A pure quadratic equation is reduced to the form. Now what is the pure quadratic equation? How do we write pure quadratic equation? Ax square plus c is equal to 0. Correct? Ax square plus c is equal to 0. That is what we saw here. If you see this part, ax square plus c is equal to 0. Correct? So now what they are trying to do is, instead of c, they have taken here it as d. That's all. Okay, they have taken this as d. Now here what is going to happen? I am going to just change the side. I am going to take d to the other side. So a into x square is equal to d. So I can get that a below. So x square is equal to d by a. Now this square, if one side it is square and if it goes to the other side, it's going to become square root. Okay, if it's going to become square root on the other side. So that is what has happened. X square onto the other side has become square root. And whenever there is square root, you can either have a plus value or a minus value. How you can have a plus value or minus value? Just take an example. Minus 2 into minus 2. I'm just finding minus 2 square. So minus 2 into minus 2 is also plus 4 only. Plus 2 into plus 2, that is 2 square, is also 4 only. Okay. What I'm trying to do, even if I square minus values, I'm gonna still get positive value, and for positive value I will obviously get positive values. Okay, so that is why what we are supposed to do is, in this, whenever you have square root, it means you can have either plus value or minus value. So that is why you have plus and minus, plus or minus. So first root is going to be plus, that is d by a, and the second root is going to be minus d by a. Again you have square root. So one can be plus value and the other one can be the minus value. So this is how you find the two roots or two values for the quadratic equation. So this is the introduction part of the quadratic equation. Okay, we shall solve the problems in the tomorrow's class. So copy down all of these problem and the introduction of quadratic equation in your notes. I shall send few more problems to practice, the statement problems of linear equation. Please do practice them. Okay, thank you students.